Greetings, YouTube. Beautiful mind here. So we're gonna go ahead and get started with this lesson. So I'm posting it in the night, but it's gonna. So I just wanted to be ready and available for the students in the morning. A few notes. Let me see. So this is we're in the middle of week 4, exam 2. Just trying to make sure the audio is fine. All right, audio sounds fine. So. Exam 2 is posted. It should be available. It is due this Saturday by 11:59 p.m. Um, what is it? You get unlimited attempts until the deadline. Past the deadline, then there's going to be a late penalty. So up until this Saturday, you can take it as you get unlimited attempts. You can get whatever score you want. Okay, and your grade is going to come from basically I just pull whatever I see on Pearson. Check Moodle to see your current grade. It is updated for weeks 1, 2, and 3. So yeah, we're in week 4. I can't think of anything else. The main thing is we got an exam this week that's due Saturday. Get our assignments. So the due dates are next to each assignment in Pearson. And be sure to do the participation and honesty quiz on Moodle. I think that's available for this week as well. So, you just want to be sure to get that submitted. Okay, I can't think of anything else. So as you have questions, just write them down. And you have to reach out to me so we can make sure that your questions are being answered and that you know what you're doing. All right. So we're going to continue chapter 8 of the discussion on systems of linear equations, and we're going to move into section 8.3, solving system of equations by the addition method. Okay, I think last time we did the substitution method, so which is another technique that we have for solving a system. So the objectives here are to solve a system of equations by the addition method. To solve a system of equations using the addition or elimination method, this is one of two. If necessary, rewrite each equation so that the terms containing variables appear on the left side of the equation and any constants appear on the right. If necessary, multiply one or both equations by a constant so that when the equations are added, the resulting sum will contain only one variable. Add the equations. This will result in a single equation containing only one variable. Solve for the variable in the equation from step 3. Substitute that value into step 4, and then repeats 2 and 4 to eliminate the other variable, and then check. So that's kind of a mouthful. I feel like this is easier to understand if we just work an example or two. Let me see. I just don't want to see the solution. Yeah, it's showing too much there. So let me start by getting a copy of this. I don't need that one. You can delete that. And let me crop this. Okay. Then we can drop it right here. And let's add a page right there. Okay. All right. And one other thing that I like to do, let's go to paper, and this is some graph paper. All right, cool beans. Okay. Black is fine. So solve the system of equations using the addition method. So let me start by getting a copy of the original. So the original that we have is, nope, wait, that's not gonna work for me. Let's go like here. We have x plus 3y equals 13. And we have x plus 4y equals 18. All right. So if we're going to use the addition method, the goal is we want to get one of these variables to be the exact same, but only be different by sign. So you see how the x's, they already have the same coefficient, but since they're both positive, we want one to be positive and one to be negative. So we can do this by multiplying an entire row by a constant. So I'm going to multiply row 2 by -1. All right. And I'm going to distribute this -1 across all parts. Okay, if we do this, the first one just comes down and stays as is. X plus 3y equals 13. Now if we multiply the second row by -1, we're going to get -x minus 4y equals -18. So now if we add the two equations together, notice that the x's cancel. Okay. 3 plus -4 is -1, so that's going to be a -1y. 13 plus a -18 is -5. multiply both sides by negative, and y equals 5. So if y is equal to 5, we can take this and plug it into either equation. Let me see. I'm going to choose one by random. The time is 12. So I'm going to do a 1 because I saw the 1 first. Actually, I saw the 2 first. I'm going to plug it in equation 2. So then if we plug that 5 in the equation 2, it doesn't matter which one you plug it in. As long as it's correct, it'll work. 4 times 5, it should equal 18. So now if we solve, we get x plus 20 equals 18. Subtract 20 from both sides. X equals, what is that, negative 2. So our claim is that the ordered pair negative 2 comma 5 should work in the original. Okay, let's see. So let's do a quick check. Say check. So if x is negative 2 and y is 5, so then is it the case that negative 2 plus 3 times 5, does that equal 13? Negative 2 plus, what is that, 15? Does that equal 13? 13 indeed equals 13. So that checks out. We need to check the other one as well. So is it the case that, again, this is another check. Negative 2 plus 4 times 5, does that equal 18? Negative 2 plus 20 equals 18. 18 equals 18. So that checks out. So then we can stand by the solution, this ordered pair of negative 2, 5. I think last time we talked about if we wanted to solve this graphically, if we graph both of these lines, they should intersect at the point negative 2 comma 5. Okay. I'm going to let that be. So we got negative 2 comma 5, and you see it there. So let's do another one. Let me get a copy of this. Get rid of this. Oh, I totally just got sleepy all of a sudden, and I just started. So we'll see how it goes. I should be able to make it though. I was totally gaming, and then I don't know. I was so revved. I was like, well, let me just try to ride the wave of this energy, and like go ahead and do a lesson for tomorrow. And after about a couple of minutes, I was like, oh, ready to go to sleep now. But it's okay. So let's give this example a go. So we're asked to solve the following system of equations using the addition method. So basically the same thing, right? Let's start here. Get a copy. So we have our 2x plus 3y equals 6. And we have 5x minus 4y equals negative 8. Okay. So the goal is that we can choose a variable. We want to get we want to get the coefficient in front of the variable to be the same number with opposite signs, right? I think I'm going to cancel, because I only have to do one. No, I'm going to have to do twice. So since the y is already opposite signs, I'm going to get the y's to be the same number, but with opposite signs. So the least common multiple between 3 and 4 is 12. So I want to get both of those numbers at 12. So I'm going to accomplish this by multiplying by the constant. I'm going to multiply by what? 4 on top. So I'm going to distribute a 4 on top. And I think we need, what, a 3 on the bottom. Okay, if we distribute a 3 here. All right, let's see what happens. Okay. So then 4 times 2 is 8x. 4 times 3 is 12y. 4 times 6 is 24. 3 times 5 is 15x. 3 times 4 is negative 12y. 3 times 8 is a negative 24. Uh-oh, let's see what happens. So now if we add the two equations together, this adds to 0, this also adds to 0. So the equal sign comes down. 15 and 8, what is that? 23. That's going to be 23x equals 0. We divide both sides by 23. X is going to be 0 divided by 23. Quick question. Is this equal 0 or is this undefined? So as a quick recap, let me use this color. I think earlier we said that 0 divided by some number, this is okay. So this is equal to 0. But some number divided by 0 that's a KO. You want to knock that out. So that's undefined. Okay. So in this case, we have okay. So this is going to be equal to 0. All right. So if x equals 0, then we can go back and solve for y. I'll just choose equation 2 since I think I chose equation 1 last time. I don't know what I chose last time. I'm going to choose equation 1. I'm just trying to be random. So then 2 times 0 plus 3 times y should equal 6. So this means that 3y equals 6 because all of this goes to 0, right? Divide both sides by 3, y equals 2. Okay, so our claim is that the ordered pair, it looks like 0, 2. Our claim is that the ordered pair 0, 2 should work and should be the solution to the system. Okay, let's see. So if we do a quick check, 3 times 2 is 6. That checks out. -4 times 2 is -8. So that solution, that ordered pair works in both equations. Okay. So again, as you watch, just if anything is not clear, be sure to write down your questions and email me. I'll make dedicated YouTube videos answering you all's questions. I typically don't get a lot of students asking a lot of questions, but the ones that do genuinely ask questions, and not just asking questions for the sake of asking questions, but actually asking questions, because they tried it, they couldn't figure it out, and so they asked them. Those students typically do well in my class. But that's neither here nor there. Was that oh, is this another one? Okay, so here, let's do this one. We are breezing through this, and I only want to do these 2 sections for today. Okay, and because I really want to be available during class time for questions, which students typically don't ask, but that's okay. All right. I wanted to go here. Oh, come on, stop doing it. Okay, it's gonna keep acting up. All right, let's take that. I'm gonna drop it here. So we want to add a page. All right, I think we're good to go. Yeah, I don't like the way that looks. Crop. That's better. Okay. That looks better. Yeah, that's fine. Okay. So solve the system using the addition method. So let's do it again. So we have 2x plus y equals 3. We have 4x plus 2y equals 12. Let's cancel the x. So if we're going to cancel x, again, the goal is to get the numbers to be the same, but have opposite signs. Let's multiply row 1 by, I think, -2. Okay, if we distribute a -2 into every term, that's going to be a -4x minus 2y, -6. And then we got 4x plus 2y equals 12. So when we add these together, this adds to 0, this adds to 0. Okay, so on the left we get 0, on the right we get what? 6. Is this true or false? This is false, all right? So we're going to say the solution set is the empty set or the null set, meaning that there is no solution. All right, so when the variables cancel like that and you finish with a false statement, that's an example of a contradiction. All right, and that means there's no solution. It's no solution. No, there's no real number that's going to work here. Okay. Okay, so I think we see it there. So let's do this one. Okay. Gonna drop that there. Gonna add a page here. Boom. Much better. Come on. Okay. So we're asked to solve the system. Let's do the same thing. Start by getting a copy of the original. X minus 1/2 y equals 2. We also have y equals 2x minus 4. Okay, I don't know why they did it this way, but let me start by getting them to look similar. So I am going to subtract the 2x on both sides just to get them similar. Yeah, I think that'll be the simplest thing. So the first one's just going to come down, x minus 1/2 y equals 2. If we subtract the 2x from both sides, we'll get negative 2x plus y equals negative 4, right? Okay. So now the goal is to choose a variable. We want the number in front of the variable to be the same, but only have opposite signs. So I'm going to cancel out the x. So to cancel out the x, we can multiply that first row by 2. Multiply by 2, it should work. Okay, let's see what happens. So then we'll get 2x minus half of 2 is 1, so that's going to be the negative 1y equals 4. And then this other one is just a negative 2x plus y equals negative 4. If we add these together, we finish with 0 equals 0. Is this true or is this false? This is true. So this is an example of an identity. One equation is a multiple of another. It looks like the second equation is the first equation multiplied by what, 4 or something like that? 2? 2 multiplied by 2, right? Anyway, the first equation is a multiple of the second equation. So this is going to have infinitely many solutions, and all the solutions are going to take on the form, no matter what x we choose, the y value is going to be 2x minus 4. All right? So like you can test this by choosing any value for x, finding the corresponding y, and then testing the order pair in the original. For the sake of time, I'm not going to check it, okay? I'm just going to accept it for now. So infinitely many solutions. That's an example of an identity. Okay. Since 0 equals 0 is a true statement, the system is dependent and has an infinite number of solutions. When graphed, both equations will be the same line. Okay. So that actually closed out section 8.3. Solving the system of equations using the addition method. So now we're going to continue chapter 8 with section 8.4, system of equations, applications, and problem solving. Okay. So we want to use system of equations to solve application problems. We have this example. It says Phil is building a rectangular patio out of concrete. When he measures the two angles formed by a diagonal, he learns that angle X is 22 degrees greater than angle Y. Determine the two angles. Okay, let's give it a go. We got this. Let's add a page. All right. He learns that angle X. Okay, so let's translate that sentence. It says angle X is 22 degrees greater than angle Y. So the direct translation is that X is going to be equal to angle Y plus 22 degrees. Notice if he's doing a rectangular patio, if we say angle X plus angle Y, they should add up to 90 degrees. Okay? Because it's the corner of a rectangle. The corner of a rectangle is 90 degrees. Those are complementary angles, so they should add up to 90. Okay, so now we have two equations, two unknowns we can solve. Does it matter which technique we use? I don't think it matters. Yeah. So since it doesn't matter, I'm going to use, since we've already solved for one of the variables, I'm just going to use substitution. So if x is equal to there, we can take that and substitute that into equation 2. So then it's going to be the case that 22 plus y should equal 90. All right, combine like terms. So if we combine like terms, we'll get 2y plus 22 equals 90. If we want to solve for y, let's do the inverse operation for the 22. If we want to move the 22, the inverse operation is going to be subtraction. So subtract 22 from both sides of the equal sign. So on the left, we're going to be left with 2y. Let me see, 70, 68, right? It's going to be 68 there. If we have 2 times y, the inverse operation is division. So we're going to divide both sides by 2. We're going to have y equals 34. Okay. So if y equals 34, then that means that x is going to be 22 plus 34. So then x is going to be equal to, what is that, 56? 56. So it looks like x is 56 and y is 34. What are these? Degrees? Degrees. Okay. Let's go back and check it in the context of the original. Okay. So, let's see. When he measures two angles formed by a diagonal, he learns that angle x is 22 degrees greater than y. So if we have 34 plus 22, 56 is good. And then they add up, they should also add up to 90. 50 and 30 is 80 plus another 10 is 90. So they add up to 90 and x is 22 degrees more than 34. That's about the best that we can do. Okay, so the two angles should be, x should be 56 degrees and y should be 34 degrees. Okay. Ooh. We're actually almost done. It's only like 10 more slides. I think that's why I wanted to go ahead and do it, because I felt like it wasn't going to be long. And again, my intent is to be available during class time for questions. But I really just want to get these presentations loaded before class time, so that way when class starts, you can just come to my channel, load the video, and watch the lesson for the day. Okay. So again, and with these examples, what's a good idea is, like, when you see the original question, pause the video, write it down. See, can you answer the question before you see my answer? Like, the more you can do it without my help, the better off you'll be. I know this sounds a little bit contradictory, but the following is the truth. Honestly, mathematics, you really teach yourself. I'm really here just for support. Even if we were meeting in person, you really teach yourself, because whoever's doing the math is learning it. And I know a lot of students respond, well, if I'm teaching myself, what do I need the professor for? So then it's like, well, you're not going to know everything. My job is here to help you stay unstuck or not be stuck for too long. You want to be frustrated for a little bit, but too much frustration and you'll be discouraged, right? So you want to be frustrated a little bit, and you're like, then once you can't figure it out, you're like, hey, Mr. Pfeiffer, I could not figure this out. Could you help me? Then I'll offer a suggestion. You'll be like, oh, I get it now. And it'll click. Versus if you never think about it and you just try to depend solely on what I'm saying, you're going to be overwhelmed and you're not going to get it either. Really, you got to do it yourself. And I'm just here to kind of keep you unstuck. Another way to look at it is, I got the following from, I think it was Tiffany Haddish when she did her interview on The Daily Show. She was talking about when she was practicing her comedy with Richard Pryor. She was doing stand-up for him, and he was not liking it. He was like, "What are you doing?" She was like, "I'm doing stand-up." He was like, "No, you're not. You're giving me a headache." Richard Pryor said to her, "Do you know why people come to a comedy club?" And she's like, "To have a good time." And he's like, "That's right." And he was like, "Do you know how to tell if your audience is having a good time?" He was like, if you want your audience to have a good time, you got to have a good time, right? He was like, my job as your coach is to tell you what you're doing wrong. Actually, this I missed the point. The point actually came from Kevin Hart, not Tiffany Haddish. That first part did come from Tiffany Haddish, but Kevin Hart, when he was training with one of his coaches, said his coach said to him, "My job is to tell you what you're doing wrong. Your job is to figure out how to get it to work for you." So it's the same thing here. As your instructor, I'm more of a guide. My job is to tell you what you're doing wrong. Your job is to figure out how to get it to work for you. The other part about having fun, it still holds, but I was really trying to get to the Kevin Hart part. Anyway, so, long story short, you have to do it yourself, and then you just want to have support to get your questions answered. But if we're not liking our experience, more than likely we're not asking the right questions. All right. Okay. So I think we did that one. Let's give this one a go. Let's look at this one. And let me go ahead and add a page because I know I'm gonna need a page. Totally sleepy, but that's okay. Okay. So it says Bob and Jim live 420 miles apart. Sometimes they meet for lunch at a restaurant somewhere between the towns where they live. On one occasion, they left their house at the same time, and they both arrived at the restaurant 4 hours after they began. Determine Bob and Jim's speed if Bob drove an average speed of 5 miles per hour faster than Jim. Okay, so we have this nifty little image. So I consider this this is a distance equals rate times time problem. So I like to do these with the table. To me, the simplest way is with the table. I think I got the hang of the table. Now, this is actually my first time doing this question, but doing this specific question, but I've done this technique a lot of times. So I'm going to apply what I've done in the past. So what we have Bob versus Jim, right? So let's do Bob here and then Jim here. Okay. So again, the formula that we're using is distance equals rate times time equals distance. Okay. So what we're going to do is we're making a table. Why can't I get a rectangle to appear there? Try it one more time and just do it smaller. Maybe that'll help it. There we go. So we're just making a table. We're going to say Jim versus Bob, and actually it might help if I put it there. There. Then we're going to go like this. We're going to do like this and like this. Okay, and we're going to drop one here. That's crooked, so that's not going to work for me. Okay, so we're going to make a table. So let's fill in what we have. Let's read it again. So it says Bob and Jim live 420 miles apart. Sometimes they meet for lunch at a restaurant between the two towns where they live. On one occasion, they left the house at the same time. They both arrived at the restaurant 4 hours after they began. Okay, so on this occasion, both of their times were 4 hours. Let me use this color. So this is in hours. So both of their times is 4 hours for this one. It says determine Bob and Jim's speed if Bob drove an average speed of 5 miles per hour faster than Jim. So we're going to let Jim's speed be R, and we're going to let Bob's speed be what? R plus 5. All right? And the units here are miles per hour. Okay. So Bob's rate is going to be R plus 5. His time is 4. So his distance, again, distance is going to be rate times time. His distance is going to be 4 times R plus 5. Jim's distance is going to be 4R. Okay, one more piece of information. So they're meeting at a restaurant halfway between the two, but the total distance from Bob's house to Jim's house is 420 miles. So if we say Bob's distance plus Jim's distance is going to total 420. So Bob's distance being 4 times R plus 5 plus Jim's distance being 4 times R, that should total 420 miles. All right. At this point, we have one equation, one unknown we can solve. Now, I'm pretty sure the text probably did it a different way. They probably used a system of equations, but this is just the way I do these. And I didn't even think about it. It was clearly a distance equals rate times time. You fill in what you have, and this is how it comes out. Okay, so, all right. So then now we have one equation, one unknown, so we can solve. Let's start by distributing this 4. If we distribute the 4, we're going to get 4r plus 20 plus 4r equals 420. 4r plus 4r is going to be 8r plus 20 equals 420. Subtract the 20 from both sides, so then we get 8r equals 400. Divide both sides by 8, r equals 50 miles per hour. So Jim's rate should be 50 miles per hour. So we're going to say Jim should have traveled at 50 miles per hour. Nope. And Bob should have traveled at 55 miles per hour. These answers are reasonable. We didn't get anything outrageous like 300 miles per hour. These are reasonable answers for this type of thing. So, okay. Notice that Bob, and then, we can confirm, for instance, if Jim is traveling at 50 miles an hour for 4 hours, that means he should do 200 miles. If Bob is traveling 55 miles per hour for 4 hours, 220. So 220 plus 200 is 420, right? So we're just checking it in the context of the original, 50 and 55. Right, now let's look at how they did it. The system is 4 times x plus 4 times y equals 420. Okay, x is going to be Bob's speed. They do theirs different. If you want me to explain it, their technique, I will. Just reach out to me. Okay, so Bob's rate is x and Jim's rate is y, since they're going at 2 different rates, which is fine. But I like the way that I did it. It's essentially the same, but I feel like introducing more variables makes it more confusing. So that's why I didn't do it that way. Okay. But it looks like we got the same result. Let's do another one. Okay. Let's add a page here. Totally sleepy. Okay. But we're actually almost done. We only have like a few more slides. It's not bad. Let me see. Can I see the time here? That's okay. All right. So it says Professor Barton needs 60 liters of 15% sulfuric acid solution, but only has 5% and 30% sulfuric acid solutions on hand. To obtain her desired mixture, how many liters of 5% sulfuric acid and how many liters of 30% sulfuric acid should she mix in order to achieve her desired result? Okay. Oh. Yeah. No. I don't want to see the answer. Okay. So with these mixture problems, I usually use the following formula, or it's not really a formula, it's just a structure. So I'll say percent of the first substance times the amount of substance number 1 plus percent 2 . Hey Google, change the light brightness to 100%. The percent of the second object, so I have my timer just went off for at this hour. What light is that? Hey Google, never mind. Okay, sorry about that. So percent of substance number 2 times the amount of substance number 2 equals percent final times amount final. Give me just a moment to get this on one line because I ran out of space. Then let's go like this. Okay, so whenever I work these mixture problems, I'll use this. Percent 1 times amount 1 plus percent 2 times amount 2 equals percent final times amount final, okay? So let's see if we can fill in these components. It says Barton needs 60 liters of 15% solution. So he wants to finish with, or she wants to finish with 60 liters. The units here are liters, so these are liters. 60 liters of 15, and she wants the final percent to be 15%. Okay. Then it says she only has 5% and 30. So the first percentage that she has is 5%, and she also has 30%. Okay. Let's try to get these together. Sleepy. Okay. How many liters of the 5% and how many liters of the 30? Okay. So if it says how many liters, we're going to let X be the liters of the first thing. So if X is the amount of liters of the first substance, how can we get an expression for the liters remaining for the second substance if she wants a total of 60? So X plus the second thing equals 60. So we can express this second one as 60 minus X. So let me do it. Let me get a copy. I just want these guys. Okay. I don't like the way it looks. Hang on. I'll do one other thing. I'm going to just take all of this. I just want it to be uniform. I'm going to put you there. You can go there. And then you go here. And then we're going to go like this. And you go here. All right. Okay. So if we had X liters of the first substance and we want to finish with a total of 60, that means the amount for substance number 2 is going to be 60 minus X. At this point, we have one equation, one unknown we could solve. Now, we should convert the decimals to percents and then get rid of the decimals. But what I've found with a lot of these mixture problems like this, you can actually just drop the parentheses and it's okay. It'll work. Okay. This is fine. So then what we're going to have 5x plus 30 times 60 minus x should equal, what is that, 600 plus, let's see, 60 times 10 is 600, 60 times 5, 6 times 5 is 30, so 300, so 900? I think that's 900. Six times 15, 60 plus 30 is 90, so 900, okay. All right, so if we keep going, we can distribute this 30. Let's see, so we get 5x, so 6 times 3 is, what is it, 18, so then 1800 minus 30x equals 900. Okay. So what is that, a negative 25x? Negative 25x? I feel like I'm missing something. Something don't feel right. But let's keep going. Okay, no, we're fine. If we move the 18 to the other side, the 1800, 900 minus 1800 is what? Negative 900? Divide both sides by negative 25. X equals, so 4 times 9 is 36. Okay, I think that's okay. So then X equals 36 liters. So the amount for substance number 1 should be 36 liters, and that means the amount for substance number 2, 60 minus 36. So then 30, 24, 24 liters. Okay. So let's see, how do we do? Now we should check it into context and make sure the numbers work out. I am a little tired, so I'm just going to kind of look at the answer and go with it. So 36 liters of the first one and 24 liters of the second one. Yeah, they do have the decimals. They did a system of equations. 36, right? And 24. So 36 of the 5% and 24 of the 30 to get 60 liters of the 15. Oh, and that was it. Okay. So on that note, we're actually going to end the lecture here. Let me get rid of this paper. Okay. So I'll go ahead and load a copy of these notes into our box folder. So keep in mind that all of the writing that you see me doing on the screen, you can actually access it from our box folder on Moodle. Okay. There are 3 main points that you should be accessing on a regular basis when it comes to my class. The first is Pearson, okay? That's where I'm going to be pulling your grade from, so just be sure to get your assignment submitted promptly. You get unlimited attempts at all assignments prior to the deadline. Past the deadline, there's going to be a late penalty. Secondly, it's going to be my YouTube channel, so go ahead and subscribe to it with your notifications on, because that's where I'm going to be posting the lectures. And then third, you just want to be sure to forward your GMC email to an email that you check regularly, so that way you can get my announcements and updates so you don't miss anything. Okay. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.